Imagine being able to solve a problem that would take a traditional computer millions of years to compute in just a few seconds. Welcome to the mind-bending world of quantum computers. Machines that leverage the quirks of quantum mechanics to perform calculations at blistering speeds. Today, we're going to unravel this complex subject, exploring the potential power of quantum computing and why it's the next big thing in the tech world. So, what exactly is a quantum computer? Let's dive in. In simple terms, a quantum computer harnesses the peculiar laws of quantum mechanics to process information. Now let's break it down. Picture a traditional computer. It operates using bits, the smallest units of data, which can be either a 0 or a 1. These bits are like light switches. They can be either on or off. Now let's dive into the quantum realm. Quantum computers use quantum bits or qubits. Unlike classical bits, a qubit can be both 0 and 1 at the same time, thanks to a principle called superposition. Imagine a spinning coin. While it's in the air, you can't say for sure if it's heads or tails. It's in a state of superposition, much like a qubit. Then there's entanglement, another unique property of quantum mechanics. When qubits become entangled, the state of one qubit becomes linked to the state of another, no matter how far apart they are. Think of it as an invisible thread connecting two separate qubits. Change the state of one, and the other changes instantly. These properties allow a quantum computer to process a vast number of possibilities all at once. Instead of working through one calculation at a time, like a classical computer, a quantum computer can explore multiple paths simultaneously. To illustrate, imagine you're in a maze with many paths. A classical computer would try one path, then backtrack and try another until it found the exit. A quantum computer, however, could explore all paths at once, significantly speeding up the process. Now, this isn't to say quantum computers will replace classical computers. They're tools with different strengths. Quantum computers excel at complex problems and simulations, while classical computers are still perfect for our everyday tasks. Sounds complex, doesn't it? But this is where the magic of quantum computing lies. You might be wondering, how does a quantum computer differ from the computers we use today? Well, let's dive right into it. At its core, the fundamental difference between a classical computer and a quantum computer comes down to their building blocks. Classical computers rely on bits, which can either be a 0 or a 1. These bits are like tiny switches that can be turned on or off. On the other hand, quantum computers use quantum bits or qubits. Unlike classical bits, qubits can be both 0 and 1 at the same time, thanks to a quantum quirk called superposition. This ability gives quantum computers a significant advantage over classical ones, as they can process a vast number of possibilities all at once, but it doesn't stop there. Qubits can also take advantage of another quantum phenomena known as entanglement. When qubits become entangled, the state of one qubit instantly influences the state of another, no matter the distance between them. This unique property allows quantum computers to process information in a way that classical computers can only dream of. Now, let's talk about speed. Quantum computers have the potential to solve complex problems millions of times faster than classical computers. Imagine trying to find your way out of a maze. A classical computer would try every possible path one at a time, while a quantum computer could explore all paths simultaneously, but it's not all about speed. Quantum computers also shine in solving complex problems, especially those that involve a lot of variables. They're particularly good at tasks like simulating the behavior of molecules at the quantum level, which is a huge challenge for classical computers. However, it's important to note that quantum computers aren't here to replace classical computers. They are tools designed for different kinds of tasks. You wouldn't use a quantum computer to write an email any more than you'd use a supercomputer to make a cup of coffee. Quantum computers, therefore, have the potential to revolutionize industries and fields that rely on complex computations. So, what does the future hold for quantum computing? Quantum computing is on the cusp of revolutionizing numerous sectors. In medicine, for instance, quantum computers could lead to significant advancements. They could model complex molecules, accelerating drug discovery, and potentially help us understand the very building blocks of life. In the realm of cryptography, quantum computing holds the potential to render current encryption methods obsolete, while also offering new, unbreakable codes. This could redefine the very concept of online security. Turning to climate science, quantum computers could simulate intricate climate patterns, aiding in the prediction of natural disasters and the development of effective strategies to combat climate change. However, it's important to understand that quantum computing is not without its challenges. One major hurdle is error correction. Quantum bits, or qubits, are extremely sensitive to their surroundings, making them prone to errors. Finding reliable ways to correct these errors is a crucial step in the development of practical quantum computers. Another challenge lies in maintaining stability. Qubits need to be isolated from all external influences, which is a tough task to accomplish. These challenges, while significant, are not insurmountable. The future of quantum computing is bright, with researchers worldwide tirelessly working to overcome these hurdles. Indeed, while quantum computing may not be mainstream yet, its potential is mind-boggling. So, what should we remember about quantum computing? Well, first and foremost, quantum computing operates on a completely different level than classical computing. It's not just about zeros and ones anymore with quantum bits or qubits. We're playing in a world where things can be both a 0 and a 1 simultaneously. This is the concept of superposition, and it's at the heart of quantum computing. Next, quantum computing has the potential to revolutionize many fields, from cryptography to weather forecasting. It can process complex calculations at a speed that classical computers can only dream of. However, it's not all sunshine and roses. Quantum computing faces significant challenges, including the need for extremely low temperatures and the issue of quantum decoherence. But the most important takeaway? Remember, quantum computing isn't just about faster computers. It's about fundamentally changing how we solve problems and understand the universe. It's a thrilling ride, and we're just at the beginning. Buckle up because the quantum revolution is coming.